If you think you're ready and you've got a watertight proof, you can start your poster. All right. Do you have any? Let's see. You did your givens, right? So, what are the criteria for a square?
Perpendicular diagonals.
Okay. What else?
Diagonals are congruent.
Okay.
Yeah.
Anything else?
That's the intersect of the midpoints.
Okay, the intersect of the midpoints. Okay, good. How do you? So, how would you have to? What do you need in order to prove that it's a square?
We need to find that these two lines are also parallel, so we need to find the alternate right angles.
Okay, so you have to prove these two sides parallel. What else do you have to prove for a square?
Oh, this is 90 degrees.
Okay, and then there's one other thing.
Those sides are congruent.
All the sides are congruent. Okay, good. So you have three things to show. All right, make sure before you finish your proof that you've shown all three things, okay?
Mistakes.
This line has to be bisected, or has, so is that what you call it? This line has to be bisected, but this line can't be.
Oh, okay. It's on there. What you would say is, you could say exactly one diagonal is bisected.
Okay, so if the diagonals are not congruent and are perpendicular, and exactly one is bisected, then it is okay.
Now I want to ask you a question. Could they be the same length?
Which one?
Could the diagonals be the same length if it's a
Diagonals
kite?
can't be the same length.
Would you
Wait,
test?
No, they can be the same length, actually.
Would you test that before you put that statement in?
No, we did test that. We said that the diagonals can be made from a long and a short stick, or two long sticks.
Okay. All right.
I wrote that wrong.
All right. Good. All right. Okay. So, does everyone have something important to do? All right. I wonder if people should kind of start your poster now. Like maybe somebody could start writing if the one you chose and all that. Yeah.
Show us that rule about if you divide an angle and a segment into two congruent segments, then as the same congruent segment with it's something.
Oh, is that perpendicular?
No, it's like the division property, I think.
Oh, division.
Oh yeah, the addition properties. No, not. Okay, just call it the division property.
Long and long will make nice.
So, no, right now we just have to
We know it.
define this.
We know it because of step 6.
You want to write it out? I'd rather write it out. Like, not actually list. I guess we could just list it. But you know, in software, she would still make us write it all out. I mean, still. I mean, I'd rather get.
No,
I'd rather.
up there.
What?
Up there, they didn't, because Emily put the last one, which was how it was parallel.
Just put the numbers?
Yeah.
Okay, then just put the numbers.
You know what you might say, which that's correct with there, but it's a little incomplete, is that if you would say, because what are you trying to prove?
Rhombus.
But how do you know what a rhombus is?
Define what rhombus is.
By the definition of a rhombus.
So write the definition of rhombus?
You say definition, and then you might put in the step numbers that show it.
Okay.
So you could just, the reason could be definition of a rhombus.
Okay, cool. Thank you.
By definition.
So, the definition.
These two sides have to be congruent.
Okay.
These two sides.
Okay, Rose, I'm going to interrupt you because you're telling me the definition of a isosceles trapezoid. What I'm asking you is, what are the criteria for the diagonals? What's going to be your if statement?
If the two diagonals are the same length and they
Do you feel like you're on the spot? I'm sorry. I didn't mean to put you on the spot. I want to make sure everybody in your group is together, though, on what things do you need? What are the exact attributes you need for the diagonals in order to guarantee that it's an isosceles trapezoid? And what is the definition of an isosceles trapezoid? Those are two separate things you need, and then the proof. Okay, so stick together. And Rose, you can demand your right to understand, okay, what they're talking about?